right, so we're going to be continuing with exponential and log functions. The rest of the chapter is actually going to be based on the solving with logs. So we're going to find solutions of exponential equations, and then we are going to use the laws of logs to solve as well. Okay, so we're doing exponential and log equations. So some of this you might remember from a previous class, solving with logs. You are going to have to use your exponential function. And when you're solving exponential, you are going to be using logs. So in your book, they give you some guidelines here. So if you are solving an exponential equation, you want to get that by itself on one side of the expression. Okay, the exponential expression is going to be that b to a power. So when it says isolate that expression, that's what it means. Okay, and then you are going to take the log of each side. So when you are taking the log of each side, okay, we use that power law to bring down the exponent so that we can solve for the variable. When you're taking the log of each side, you have some choices. So you can take a log with the same base as the exponent. You can use the common log, which is base 10, or you can use the natural log. Okay, so we're going to look at those different situations first. Okay, so in example 1, we're solving the exponential equations. When we go to the back before we solve, we're going to go over those guidelines for logs. Okay, and again, we are rounding to 4 decimal places here. All right, so for part A, we have 3 to the power of x plus 3 equals 5. Okay, so if we want to use the power rule to bring down the exponent, remember that you can have your value cancel out if they have the same base. Okay, so think about what log you want to take of both sides. And again, there's more than one way to do this. Okay, so for this one, I would suggest that you take the log of the base because you just have a number over here. So if you take the log base 3 of 3 to the x plus 3, okay, and you take the log base 3 of 5, okay, I want you to write out what happens on both sides. Well, really just on the left side. And then you are going to need your calculator for this because we're rounding the 4 decimal places. Okay, and then just like before, we are not going to be rounding until the end. So according to the power rule, this x plus 3 is going to come down in front. Okay, and then log base 3 of 3 is just 1. That's why they cancel, because 3 to the first power is 3. Okay, on this side, I'm just going to leave it as log base 3 of 5 for right now because I'm going to have to calculate that. Okay, and then if you need to use the change of base formula, you can do that. Otherwise, in your calculator, you can just go to math, the log base, 3, 5, minus 3. Okay, and then if you need to do the change of base, because some calculators don't have that, okay, if you have log base 3 of 5, that means you would do the log of 5 divided by the log of 3. Okay, that's how you would input that in your calculator, and then you would subtract 3. So the change of base is always your log divided by the log of the base. Okay, and you can just use your common log for that. So anytime you are rounding to 4 decimal places, you are going to look at that 5th number. So you have 5, 3, and then 5, 0, 2. Okay, so that's just going to round to 5, 0. Okay, now when you are doing these, you might have noticed this little note at the bottom. If the domain for a function is not all real numbers, you should check your solution and make sure that it's not extraneous. Okay, if you don't have any restrictions like your logs or your fractions, okay, then your domain is all real numbers and you don't have to worry about doing the check. So for this, there's no number I can't plug in for x. Okay, so if the domain is all real numbers, you don't have to worry about plugging it back in and getting an error. Okay, so you can just leave that, and we will go on to the next. So this is an exponential function with e in it. And when you're solving for x here, remember that the first thing we talked about was isolating the exponential part. So in this case, your base is e. So what do I need to move over first from both sides? Yep, we're going to move over the 2. Okay, so we're going to do that using division. So if we can divide both sides by 2, we'll get e to the negative x plus 1 equals 6. Okay, when you're doing this on your homework, you need to make sure that you're showing your steps. Okay, so when you are doing the next step, it is crucial that you're showing what log you are taking. Here we took log base 3 because 3 was the base. Here we have e, and so what log has a base of e? The natural log. Yep, okay, so we're going to take the natural log of both sides, and you can write this in the same step. Just please write this in the front because that's where it goes. Don't squeeze it in on the back. Okay, so when you take the natural log and e are going to cancel each other out. Your exponent comes down in front. You're going to leave this as the natural log of 6. And then from here, you are going to solve. So we're going to subtract 1. And I'm even okay if, like, you do this. Like, you're subtracting 1 and then you're dividing by negative 1 to get your x. Because you are going to be doing that part in your calculator. So you're going to do the natural log of 6 minus 1. Okay, divide by negative 1. Okay, and if you want, you can also just write out what that's going to be. I turn my mistakes into log here. So 0.79 Let's put it right. Okay, so then when you round, negative 0.79, and then the 1, 7, the 5 is going to round that up to an 8. Okay, so this is going to be your final answer. Okay, again, you have an exponential function here where you don't have to worry about plugging something in and not getting an answer. So your domain is all real numbers. You don't have to worry about checking for an extraneous solution. All right, now for C, we have 2 divided by negative 1 plus e to the negative x equals 10. This one, your domain is not all real numbers because you do have a fraction, and we know in a fraction, you can't have the value of 0. What could I plug in for x that would make the whole denominator 0? 0, because what's e to the 0? 1. 1 plus negative 1, 0. Okay, so your domain for this one is that x can't be 0. Okay, which means the only way you're going to get an extraneous solution is if x is equal to 0. Okay, and if that happened, you'd write no solution. But if x is not 0, then you're going to have a real solution here. All right, whenever you have a fraction in the denominator, you want to start by multiplying by the denominator. You can also put the 10 over 1, and you can do like a cross multiplication. Like if you thought of it like this, you'd have a proportion, and you could multiply those two together. Okay, so when you multiply 2 by 1, you'd get 2. On this side, you'd have 10 times negative 1 plus e to the negative x. Okay, you could also write your work out as, you don't have to write both of them down, I just want to show you. Okay, you could also just rewrite, both sides are getting multiplied by that denominator. So here they cancel, that's why you're left with 2. On this side, you have this. Okay, now you are welcome to distribute. That is another way to do it, but we're trying to get e by itself, so you can also divide by 10. So if you already distributed, that is okay. We're still going to get to the same correct answer. Your steps are just going to look a little bit different. Okay, so I have 1/5 equals what's left in the parentheses, negative 1 plus e to the negative x. Okay, so we want to get that base by itself. If you distributed, you'd just be adding the 10 and then dividing by 10. Here we're going to be adding 1. Okay, so you have 1 and 1/5, which is 6/5. Okay, see if you can do the next couple steps. So when we have an e, what should we do? Okay, so once you have your e, what type of log are you going to do to both sides? Natural log. Okay, so when you take your natural log and you bring down your exponent, you have a negative x there. So negative x equals the natural log of 6/5. And then, of course, we're going to divide by negative 1. Okay, so then let's check that in our calculator. Okay, and really, you guys know when you're dividing by negative 1, it's just going to be the opposite. So let me just do that step. So you have 1,823,2. So this is going to stay. Okay, now this is not 0. Okay, so we don't have an extraneous solution. This is our solution. The only time you'd have it extraneous is if it matched this value here. All right, any questions for me so far? Huh?
When you do like, just for like a 1/5 when you're adding,
Yep.
it's wrong if you add one like after that. Have natural log of 1/5 plus 1.
Yes, those will give you different values. Yeah, so you do have to add the 1 first. Okay, and then here we have 2 different bases. All right, so when you have 2 different bases, I don't recommend doing the log of 1 base. You can do that. You won't have cancellations on both sides. So a lot of times what we do is the common log. And if you have an exponential function, all of these have been exponential, your domain is going to be all real numbers. Okay, it's just when you have a situation where it's in the denominator of a fraction that you have to be careful. So the first thing we're going to do is we're going to take the common log, and I'm going to write the steps out on the side because this tends to be the type that people get confused about. So I'd like you to have something nice that you can reference. So when you take the common log of each side, you're taking the log of base 10, okay? So this is when you have different bases. Each has an exponent. Okay, when you take the common log, you are going to use the power rule, the power law, to bring this in front. Because this is a binomial, the x plus 1, you do need to put that in parentheses. X minus 3 is a binomial. You need to put that in parentheses. Okay, there are a few different ways that you can do these next few steps. Okay, we like to distribute. So if you distribute here, you have x times the log of 6 plus 1 times the log of 6 equals, and then I want you to see if you can write out the other side. So using the distribution. So we have x times the log of 2 minus 3 times the log of 2. Okay, I think this is really similar to what we did when we were solving for inverses and we had two variables. Remember how we had to get like all the y terms on one side so we could factor it out? And we had to get all the other terms on the other side? This is very similar. We want to get all of your x terms on one side. Okay, and it doesn't matter which side. Okay, the reason why we're doing that is so we can factor out the x. Okay, once you can factor out the x, you're going to divide to solve. Okay, so if we are moving all of our x's to one side, I'm going to be moving them to the left if you want to write that down. Okay, so I'm going to be subtracting x log 2 from this side, and all you want are the x's on this side. So all I want is x log 6 minus x log 2, so I can factor those out. So if that's all I want, I'm going to move over this log 6. So minus log 6 here. So now I have negative 3 log 2 minus log 6. Okay, so if I factor out my x, I just have the log of 6 minus the log of 2. Okay, it's still equal to this. Okay, and my last step is just going to be to divide. Okay, and if you want to put like the quotes here and just write it out on this side, I'm fine with that. You're dividing just by the log of 6 minus the log of 2. Okay, you guys might remember last year we were like writing out this part. This is what you're going to put in your calculator and we are going to round to the nearest 10,000. Okay, if you put this all in at once, you have to make sure you do the parentheses on the top and on the bottom. Okay, if you put in the numerator first and then divide by the bottom, again, you just have to put the parentheses. If you want to do any simplifications with the log of logs, you can do that. Like, do you guys remember from yesterday what the log of 6 minus the log of 2 is going to be? Because yeah, log of 3, because you technically can divide. You don't have to do that. I'm just saying if you recognize that, and you're like, why aren't we simplified? Well, you can. Okay, so like I said, you can put this all in at once, -3 log of 2, but you are going to need to practice to make sure you're entering it right. Okay, and then divided by, and then we need parentheses on the bottom. The log of 6 minus the log of 2. All right. So make sure that you can get this final answer, -3.52, and then it's 371. Okay, so we talked about if the domain is not all real numbers, you should check the solution. It's as simple as this, right? Just check to make sure if there's a restriction that it does not have that restriction on it. Okay, before we go to the other side, let's just look at those guidelines for solving log equations. So if you are solving logarithmic equations, I want you to read what your steps are. So this is for solving logs. Okay, you do need to isolate the log term on one side, but you might first need to combine them. Okay, and that would be using your laws of logs. So if you are combining them, you're going to have to use those laws we learned in 4.4. And then this is a crucial step here. You are going to write the equation in exponential form. We are going to be rewriting them. So if you have the log base b of x is equal to y, you are going to rewrite it as b to the y equals x. Okay, so we're going to be rewriting some of these equations here. Now with logs, the domain is not all real numbers. With exponential equations, as long as they're not in a fraction, it was all real numbers. But remember, with logs, you can't take the log of what type of values? When we're getting errors. Yep, so you can't take the log of a negative, or 0. Okay, so we are going to have to check for extraneous solutions because of that domain. Okay, so those we're going to be writing out our checks. Okay, that is something you have to do for the logs. Okay, you do not have to do that for exponential. Okay, so for part A, we have log base 2 of 22 minus x equals 3. So we want to have the log by itself. That means we just have one log. Nothing is added or multiplied to it. We already have that. So we can start by rewriting in exponential form. Okay, so we're going to rewrite that in exponential form. So it's going to be the base. So you can think base answer exponent. This is where b comes in. Okay, so your base is 2. Your exponent is 3. The answer to that would equal 22 minus x. Okay, and from here, easy peasy lemon squeezy, algebra 1 stuff. right? We're just going to move all of our numbers to one side to solve for x here. Okay, so your x value is 14, and then we just have to check to make sure it's not extraneous. When you are checking, okay, on your next assessment, you'll have the checks. What you need to show is what you're plugging in. Okay, so your first step, all of our first steps should be the same. So if I got 14, my very first step looks exactly like my original equation. Okay, and then from here, remember, we don't know if they're equal when we're checking. So we can't use exponential forms. We have to show that log base 2 of 8 is 3. So to show that, you can just rewrite this as 2 cubed. Okay, so log base 2 and 2 will cancel, so 3 equals 3. Okay, so if that is a true statement, then your solution is right. So your solution would be x is 14. Okay, so that's a very basic one to start. Okay, for B, our first order of business is going to be to get the log by itself. So think about what you want to move away from the log, and let's do it. You just want the log term alone. So what are we going to move over first? Yeah, we're going to move over the 4. And then we don't want anything in front of the log multiplied, so then we're going to move over the negative. Okay, so step 1, we subtract 4. So we have negative log 3 minus x equals negative 1. And then we divide by negative 1. Okay, make sure you keep your parentheses. That's you.
So I was thinking I'm doing it different way. I was going to subtract the log and then subtract 3 to get the log one.
What do you mean subtract 3?
Or on the other side, or I add the log on the one side.
Oh, you can add the whole log, yeah. So then, and then you end up with this, just on the other side. Yeah, that's fine. Yep. If you wanted to make that a positive and then switch it, yes, absolutely do that. All right, so now we have the log isolated. Once it's isolated, we have to rewrite it. Okay, so once the log is alone, you need to rewrite in exponential form. You have to use that definition. So if you can't see a base, what is your base? 10. Okay, so it's base, answer, exponent. 10 to the first equals 3 minus x. Okay, so go ahead and solve that for x. And then you can start your check. Okay, so when you subtract your 3, you're going to get 7. If 7 equals negative x, then we know x is going to equal negative 7. Okay, so 7 equals negative x. Okay, so again, when we plug that in, we need to use the original equation. So it's 3 minus x equals 3, and then I got negative 7. So if you have minus a negative there, we're going to change that to a plus. Okay, so this is the log of 10. And remember, we don't know if those are equal. So you're only working with one side here. You can only work with this side. What is the log of 10? 1. Okay, so 3 does equal 3. Okay, for the log of 10, Remember, it's like that is equal to an unknown value. 10 to what value is 10? 1. That's why this is 1. Okay? All right, and then so your solution is x equals -7. Okay, and then for C, we're going to see a different type. So there's lots of different types. I just want you guys to see a variety before you do this on your own. All right, and then from here, what do you guys think? What do you guys think our first step is going to be? Before that, actually. So we do have to use those laws of logs, right? So what law of a log can I use on this side? If I'm just looking at this. I have log base 2 of 3 plus log base 2 of x. So based on what we did yesterday, what law can we use? Yeah, the product law. Good. Okay, so then here we have log base 2 of 3x. Okay, you guys with me on that part? Based on that, can you simplify this side over here using the law of a log? Okay, so if you multiply these together, 5 times x minus 2, you're going to have to do what? Distribute. So you'd have 5x minus 10. Okay, now, if the log bases are the same, do you guys remember what you can do? If the log bases are the same, okay, then the values of each of them are equal. They have to be the same on both sides, though. Okay? Okay, so if you have log base 2 and log base 2, if the log bases are the same, you know whatever the logs are of have to be equal to. Because log base 2 of 5 cannot equal log base 2 of 10, right? Whatever they're of, they have to be the same. So you can simply set 3x equal to 5x minus 10. Okay, you could also exponentiate. So if you exponentiate and you make 2 the base here and 2 the base here, what happens when you have 2 log base 2? Those cancel, so you get 3x. 2 log base 2. Okay, that is what it's based on. If you want to do a solving step, you can write that down. You could exponentiate. Now we're going to get all of our x's on one side. All right, and then our check for this one's going to look a little bit different. So we have log base 2 of 3 plus log base 2 of x equals log base 2 of 5 plus log base 2 of x minus 2. Okay, so I am plugging in 5 and I am plugging in 5. bless you. So again, we don't know if they're equal, so we are only going to do one side at a time. So on this side, you are going to use your product law. So this is going to be log base 2 of 3 times 5, or log base 2 of 15. Okay, on this side, you have log base 2 of 5 plus log base 2 of 3, which is exactly what you have there in the different order. So yes, when you have log base 2 of 15 equals log base 2 of 15, you don't even have to worry about typing in the numbers. Those are going to match. Okay, so if you have the same log base and the number on each side, you are good. Okay, so then your x value is going to be 5. Okay, now the last type you will see would be one like this. The log of x plus the log of x minus 1. Actually, you might have some with division as well. But if you do, I'm confident you'll figure it out. You can always multiply by the denominator. You have those things. Okay, so if you have more than one log on one side, okay, let's use our log of logarithms to condense those. Okay, so can you condense the right side? And then you really should be able to go to the next step. Okay, it's okay if you're getting stuck. This sometimes happens here. Okay, so then once you see you have the same log on both sides, you can rewrite it as x squared minus x equals 4x. The logs are the same. Okay, it would be like you're exponentiating with a base of 10. Those cancel, those cancel. Okay, so then we're going to have to move everything to one side so that we can factor. So sometimes you are going to have to factor. Okay, sometimes you're going to have to factor a trinomial. Okay, so if you factor out the x, this time you're going to have two solutions. Okay, so you are going to have to factor. So it's either x is 0 or x is equal to 5. Okay, so we are going to have to check both of these. All right, so when you're checking the first one, x is 0, you're going to get the log of 0 plus the log of 0 minus 1 equals the log of 4 times 0. Okay, when that happens, if you get the log of 0 here, you get the log of a negative here, okay, this is extraneous, okay, because you can't take the log of 0 or a negative. Okay, that is something you'll have to be able to explain on your assessment. Okay, so make sure you understand it's what happens when you plug it back in, because this would be a negative, that would be 0. Okay, so that's not going to be one of our solutions. So now we're going to check our other value, x is equal to 5. If this doesn't work, our answer would be no solution. Sometimes that happens. So we have the log of 5 plus the log of 5 minus 1 equals the log of 4 times 5. I always draw this line down here to remind myself that I can't use properties of equality. Okay, what I can do is use my properties here of the laws. So if I have the log of 5 plus the log of 4, that is the log of 20. If I multiply these, this is the log of 20. Okay, so my solution is x equals 5. Okay, so if you have a quadratic here, okay, at any point, how are you going to solve that? The first thing you should do is try to factor. If factoring doesn't work, then you always have the quad formula or completing the square.